how to find the reference angle for an angle between 0 and 360 that is in standard position. So if you're in quadrant 1, if the terminal side of the angle lands in quadrant 1, then the reference angle is just the angle itself. So for example, what is the reference angle of 40 degrees? 40 degrees. That's your answer. The reference angle, which is often like they just put a little hat on the original name of the angle. So the reference angle, this hat A is what I'm saying as the reference angle, is equal to 40 degrees. Okay, let's see. This is a degree example, and I'll show you a radian example for each one of these. What is the reference angle of pi over 4? Well, the reference angle of pi over 4 is just the angle itself, pi over 4. Now, you would have to first verify that those angles are in fact in quadrant 1. So you have to remember, just make a note here, that quadrant 1 is here. It's with your both x and y are positive, and it's probably the first quadrant that you ever learned about in kindergarten. That's why I think about it. It's quadrant 1 because when you like just did simple tallying in first grade or second grade, that was the only graph that you remember. So that's why I call that. That's why it makes sense to me that they call that 1. Then in second or third, in like fourth or fifth grade, probably you were introduced to negative numbers. So that's why then you had the negative, positive, and negative x-axis. Then when you grew older, then you learned about, graphing, and you also had negative y values as well. So we go counterclockwise around here, 1, 2, 3, and this is the fourth quadrant. So for an angle to be in quadrant 1, it's got to be, this is a 9-degree angle here. So it's got to be between 0, its terminal side lands between 0 and 90. So the angle kind of looks like this. It's in this area. They got so that's approximately 40 degrees. So it's a little bit harder with radians, like recognizing is that angle in quadrant 1. So, and so quickly here, let's just go over all these. And this is 0 and 90. If we add 90, this is another 90 degrees. So this is at 180. So any angle between 90 and 180 is a quadrant 2 angle. And then this one, if you add 90 again, you get 270. So any angle between 180 and 270 would be a quadrant 3 angle, and then any angle between 270 and 0, I guess, or 360 is also 360 is a quadrant 4 angle. So with radians, it's a little bit more difficult. One way of, I think the fastest way to do this is this is pi over 4. So remembering in radians, 180 degrees is pi. So this is pi. And then whatever denominator they give you, you can say this angle of 180 degrees is going to be split in 4 ways. So it's already split in half, this side and this side. So then you just split those in half. And then, so these must be, this is the whole pi. That's one full pi. And then, so this is 4 equal pieces of that. 1, 2, 3, and 4. So that means that each one of these is pi over 4. So that would be 1 pi over 4. This would be 2 pi over 4, which is also reduced to pi over 2. And then 3 pi over 4, and then 4 pi over 4, or which reduces to just pi. Okay, so that can be a way that you can quickly help you figure out, oh, is this in quadrant 1? And you could see that pi over 4 lands in this first quadrant space. Okay. course, this is first quadrant. That would be second quadrant again, and then third quadrant and fourth quadrant. So we'll be seeing some examples that are in other quadrants next. If the terminal side of an angle lands in quadrant 2, so this is what it looks like. Then what you're going to do is you're going to take 180 and subtract that angle, and that's how you're going to find the reference angle. So that makes sense because the reference angle is actually here, is measured between the x-axis, if this line is closer to the negative x-axis, then you measure from the negative x-axis here to the terminal side, or if the line in the first quadrant, if the line is closer to the positive x-axis, the terminal side, then you measure from the positive x-axis up to the terminal side. So this is the reference angle. So the angle A is that's angle A. So to find the reference angle, you take all of the blue, which is 180, and then you take away the red, and that would leave you the black reference angle that you want. Okay, so that's why we use this formula. 180 minus the angle is equal to the reference angle if the angle is in quadrant 2. So here's an example. If it's 104, if you have 104 degree angles, what's the reference angle? Well, you take 180, you minus 140, and that gives you 40. Honestly, I draw the picture every single time. 140 degrees, around there, because I know this is a 180, and I know this is 90, so I know 140 is somewhere in there. So I draw it first, and then that drawing of it helps me remember the formula of how to find it. Okay, so that angle there is 40 degrees as well. Okay, now let's try it with radians. What is the reference angle of 6/7 pi? Well, first you would have to determine where that is located, whether it is actually a quadrant 2 angle. It is, but how would you know that? So, like I said, you can just remember that 180 degrees, or 180 degrees here, is pi, one full pi, that's something. So these are sevenths pieces. So we can cut that into sevenths. Which is going to be kind of hard, but okay, so almost 3 on that side and 3 on this side, but 1 more in here. So bear with me. I will just try to do my best. 1, 2, 3, 4, 5, 6. Okay. Well, that last one was really poor, but. So I try to draw it such that 1, 2, 3, 4, 5, 6, 7. Okay, there's 7. I halfway around the circle got cut into 7 different pieces. Those are sevenths. Each one is a seventh, and this is pi over 7. That's 2 pi over 7. That's 3 pi over 7. And that's 4 pi over 7. And that's 5 pi over 7. And this would be 6 pi over 7, which happens to be and this is 7 pi over 7, which would reduce to pi. So that happens to be the angle that we're looking for, is pi over 7. So how do I find the reference angle? Well, I use this. We can't use this formula exactly because this 180 is actually in degrees. So we have to first write this a formula that's good for radians. So instead of where I have degrees in this formula, I'm going to replace it with radians. So what is 180 in radians? It's pi. So This is the equation that we're going to use for when your angle is in degrees, and that's the equation you'll use when your angle is in radians. So we need to do pi minus 6 pi over 7. Now you could just pop that in your calculator. However, something easier to do would be to just rewrite pi with a denominator of 7. So let's just think about it. We have to first write pi with a denominator, so we put it over 1. And then if I want pi to have a denominator of 7, then it means I have to multiply the denominator by 7. But if I want this to be an equivalent fraction, I have to make sure to multiply the numerator by 7. So pi over 1, or just 1 pi, or just pi, is equal to 7 pi over 7. So now I can rewrite this is 7 pi over 7, because pi was equal to 7 pi over 7. So then we can now subtract them. When you subtract fractions, you keep the denominator the same, and then you just subtract the numerator. So 7 pi minus 6 pi is 1 pi. 1 pi, or just pi over 7, is your reference angle. Okay. This is now quadrant 3. If we're in quadrant 3, let's think about, remember, quadrant 3 is right here. The angle is going to look like this. And the reference angle that we're trying to find is right here. It's measured between the terminal side and the x-axis, the closest to x-axis. So to find that angle, you take the standard, the angle as measured in standard position is this red angle. So to find the reference angle, you just have to subtract 180, which is this green part. So that's why you take your original angle and subtract 180. This is the formula if your angle is in degrees. So let's see an example. What is the reference angle of 240 degrees? First, let's verify that that's in quadrant 3. I have memorized that in quadrant 1 is between 0 and 90. Between quadrant 2 is between 90 and 180, and then quadrant 3 is between, did I say quadrant 3 or 2? But anyway, this angle is in quadrant 3, and we're doing quadrant 3 problems right now. So between 0 and 270. So in fact, 240 is between in that quadrant 3. So to find the answer, all we do is do the angle minus 180. And honestly, I always draw the picture, like I said, when I'm trying to find a reference angle, because it helps remind me of the formula. So the reference angle is 60. All right, let's see an example in radians. So like we said before, to write this is the formula in degrees. How do I translate that for a formula for radians? Just take the angle, and then you take the 180 and turn it into radians, and it would be pi. So it's the angle minus pi. So first we would have to verify that this actually is in quadrant 3. We could do that by saying this is pi, this space right here is pi, and this angle right here is pi. And so this is cut into fifths. They've cut things into fifth pieces. So I can cut pi into 5 equal pieces, well, to the best of my ability. Okay, so this might be like pi over 5. This would be 2 pi over 5 and 3 pi over 5. Um, and this is just a rough sketch drawing. 4 pi over 5. And 5 pi over 5. Okay, so then if I go one more pi over 5 over, then I would be at 6 pi over 5. So that is our angle, and it is in fact in the third quadrant. So you guys can already see we're gonna take the angle itself, this is 6 pi over 5, and we're gonna subtract pi, but I've already written pi as 5 pi over 5 here above. But just in case, you can review it on the video of kind of how I did it before, but like I can do it over here again. If I have pi and I want to rewrite it with a denominator of 5, um, I can put pi over 1, and then I put the denominator I want is 5, and then I ask, well, what do I have to multiply 1 by to get 5? Well, 5, so I have to multiply the denominator by 5. That means I have to multiply the numerator by 5, and then so it's 5 pi over 5 is equal to pi. So I can rewrite this, this pi, it's equivalent to 5 pi over 5, and now when we subtract, we just subtract the numerators, and then we get 1 pi, or just pi, over 5, and you keep the same denominator. So your reference angle is pi over 5. All right, that's an example for quadrant 3. Okay, here is an example for quadrant 4. Oh, that is subtract. It looks kind of like addition. All right. So if an angle has a terminal side that lands in quadrant 4, then the reference angle is equal to 360 minus the angle. And let's see the picture to kind of figure out why that would be true. Quadrant 4 is down here. So the angle might be here. To find the reference angle, which is measured between the terminal side and the x-axis, this is the reference angle, and this is the angle in standard position. To find this angle, what you can do is notice that the blue and red parts together make one complete revolution. So one complete revolution is 360. So that's why you do this green one is 360, do 360 minus the red, which is the angle measured in standard position, A, and that will give you the reference angle. So here's an example. If we have 350 degrees, and that's just a rough estimate of 350 degrees, it's probably way off actually, then you take 360 degrees and you back up. You have to think about how much do we have to back up to get to 350. So that means we have to subtract 350. And that's 10 degrees. So our reference angle to the 350 degree angle is 10 degrees. All right, let's see this example in radians. So because this is written in degrees, 360 here is actually degrees. And maybe to be more exact, I should have written a little 0 there for the degrees. What is 360 degrees in radians? It's 2 pi. So the formula for radians would be 2 pi minus the angle. So we need to do 2 pi minus this 11 pi over 12. First, you have to verify that 11 pi over 12 is actually in quadrant 4. So to do that, oh no, it's not in quadrant 4. I apologize, it's not. And maybe even this is a faster way for you to kind of see this. I look at 11 over 12, and 11 over 12 is less than 1. You know, it's 1 pie, it's not one full pizza. It's 1 piece missing from a pizza. So that means this is less than 1. That means this is less than 1 pi, which means it would be this is 1 full pie and this would be less than a full pie. So this is actually in quadrant 2. So I made a mistake here. Sorry. Let's think of another one. I probably am thinking of, I think I knew what I wanted here. I think I wanted 11 pi over 6. That's what I wanted. Let's do that one. Well, good thing that I verified first that this angle was actually in the quadrant I thought it was, because it wasn't. So what is the reference angle of 11 pi over 6? So first, I'd remember that this is 1 full pi. So because this has a denominator of 6, I'm interested in drawing pi over 6s, 1/6 pi. Or you can think about that as 1/6 pi. So I'm cutting this into 6 pieces. And then if I keep counting, that's 1, 2, 3, right? 1, 2, 3, 4, 5. Wait, 1, 2, yeah, this is one of them. 1, 2, 3, 4, 5, 6, 7. And if I cut the bottom also in 6s, let me just establish it. 1, 2, 3, 4, 5, 6. There's 6 equal angles in the bottom and 6 equal angles on the top. And now I just have to count 11 of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So this would be 11 pi over 6 right here. So it is in fact in quadrant 2. And notice that all the way around would have been 12 pi over 6, because 2 divided by 6 or 12 divided by 2 is 12 divided by 6 is 2, so it makes sense that this reduces to 2 pi. So it is in quadrant 4. And so to find this, the formula we'd have to use is 2 pi minus the angle. So 2 pi minus 11 pi over 6. So what I would have to do is I would have to rewrite 2 pi with a denominator of 6. So I rewrite it as a fraction by putting it over 1. And then I say I want a denominator of 6. So that means I take the 1 and I have to multiply by 6. But whenever I do the denominator, if I want it to be equivalent, I have to multiply the numerator as well. So that becomes 12 pi over 6. So I can rewrite 2 pi as 12 pi over 6 minus the 11 pi over 6. And we get that the reference angle here is pi over 6. And there we go. You could have also done this in decimal. I bet you would have gotten pretty close, if you just found what is the decimal of 2 pi, write you down your answer, 6.28 or whatever that answer is. And then if you subtract this one, then you might get a pretty close answer. However, if they are asking for an exact answer, you have to have pi in the answer. They probably do not want you to have it as a decimal. They want you to write it as pi or with the square root in it. All right. And they probably won't accept it if it's done differently. So it's best and easiest to know your fractions here. But you could have also turned this into a decimal to help you figure out which quadrant it was in. And you could have labeled, you could have calculated in your calculator, what is pi over 90? Sorry, what is pi over 2? Like what decimal number is pi over 2? And then what decimal number is pi and 3 pi over 2? You could find the decimals for those, and you could find the decimal of your angle that you're trying to find the reference angle of. And let me do that quickly for you. So pi divided by 2 is 1.57. So if you wanted to turn the angle into a decimal to figure out which quadrant it's in, then this is the way you would do it. This is pi over 2 approximately. And then pi is, of course, 3.14. And then this down here is 3 pi over 2. So 3 times pi divided by 2. This is 4.17, 4.71. And of course, all the way around is 6.28. So if you turn this into a decimal by doing 11 times pi in your calculator, you get an answer, and then divide that by 6, you would find that that's 5.75. And then that's how you would have known that that angle is in quadrant 4, because it's between 4.71 and 6.28. You also could find, then you could just subtract 6.28 minus the 5.75 to find an approximate answer. All right. I hope you found this really valuable. Have a great day. Bye.